Okay. So this case is what we call a simply supported beam. Has a span and it has a uniform load. And this is the most classical thing that you'll ever see. So if the uniform load is W, the span is L. Then simply speaking, the reactions will be the whole load, if I calculate the whole load, the total load is W times L. Agree? So the reactions will be WL over 2, left and right. So far so good? Tamam? Right. So if I go and look at my shear force diagram, I'll start with what? With this WL over 2 first. Do you agree? Fine. This WL over 2. Eh? Then it will gradually decrease. Gradually. If you take a section just before this support, and look there, you'll see what? You'll see WL over 2 minus WL. صح? WL over 2 coming up, and W times L coming down. Do you agree? Ladies, is there a problem here? Right. So this is simply negative WL over 2. So I'll have here I'll have negative WL over 2. And I'll simply connect them with what? Straight line. Because this is a uniform load, we said it's one order higher. Okay, so this is a constant, so this will be a straight line. And the bending moment will be what? One order higher than the shear force, which is a parabola. Okay? So this case, my straight line is not perfect yet. It's not a good one. Where's this thing from symmetry? WL over 2, negative WL over 2. So this is exactly at the middle. There's zero shear. Here is exactly at the middle. Right? Right. There's zero shear, so this is my shear force diagram. Right. Our bending moment diagram, since the zero shear is exactly at the middle, where am I expecting my maximum value? Exactly at the middle, at the zero shear. So the maximum value of the bending moment will be where? Here, in the middle. Okay, right. What about at the edges, at the supports? It's what? Zero. So I have 3 points to draw a curve. To draw a parabola, you only need 3 points. صح؟ مش كده؟ To draw a parabola, you only need 3 points. So the first one, the last one, the middle one. How should I calculate it? One of two ways. Either take a section in the middle and look there. So in this section, my bending moment will be what? WL over 2 times this WL over 2, the reaction, times the distance, which is what? L over 2. So WL over 2 times L over 2. Do you agree? Fine. This is positive or a negative? Is it smiling or sad? I hope. Just like that. So it's what? It's fine. Okay? Tamam? Sure. Oh, we said that this is the case for a spelling. And if I'm looking at it from the other side, هيبقى كده. So that reaction will be like this. It's smiling. Fine. What about the load? Will the load cause me a smiley or a sad face?
The load?
Oh,
Sad.
sad. So this is the positive. We said that the sad face is the negative. Okay? That's the sad guy. Midday. I think that's the fastest thing ever you can remember. مش كده؟ Smiley. Okay? But so this is the sad guy. The sad guy is the load. The load اللي هو كام? This rectangle is what? W times L over 2. And where's the centroid of this rectangle? At the middle of L over 2, which is what? L over 2 divided 2 يبقى كام؟ L over 4. Okay? So that is L over 2 times L over 4. If you do this thing back, you get what? W L squared over 4, okay, minus W L squared over 8. So this gives us W L squared over 8. Yeah. This is the maximum bending moment in a simply supported beam, in a simple beam. You need to memorize it as you need. Okay? خلاص؟ with the coming 2 courses إن شاء الله. Okay, structural design 1, structural design 2. معايا بدأ؟ Okay? خلاص؟ Please. أرجوك ما تأثروش رقبتي يعني. You don't need to go to these courses without knowing these. Okay? خلاص؟ So, WL square over 8. This is WL square over 8. Okay? That's a very well-known case. Right? But why is it very important? Because if I'm having any support condition, خلي بالك, if this thing has double cantilevers مثلا, and this is a distributed load kit, I can use this case. طب ازاي؟ if I go and draw the bending moment diagram, something like that, I'll find what? I'll have a negative moment here, and another negative moment there. Okay? And there is something here. There is a value that I don't know. So simply speaking, بصوا, look here. You connect these lines and drop a value of what? What's this ordinate? WL square. So you can get this thing. Okay? This is the general case. But imagine it like that. طيب. Clear? Clear? طيب. So this is how this guy does it. He's doing the numbers and the math and all that stuff to draw the curve. And then he's proving the WL square over 8. And again, guys, this is an American textbook. This is an American textbook. So he's drawing the bending moment. The positive is up, the negative is down. We are flipping it. Our positive is down for the bending moment. Our positive is down, the negative is up. Okay? So my positive value, WL squared over 8 is down. Okay? Right. Then, let's do this case. This case is a little bit, it's not a nice one. حقيقة. It is not a nice one. Okay? Why is it not nice? Because it's not symmetric. This is one thing. Another thing is that it's not a uniform group. It's a triangular group. So he actually did the job for me. He gave me these reactions. And again, this pad, this neoprene pad, it's actually a roller support, as you mentioned, please. Okay, so this is 16K, and this is 20K. That's a triangle. The height of this triangle is 3 kips per feet. Okay. So on. تمام. This is 6 feet, and this is 18 feet. Right. When drawing the thing here, right now we said that everything will increase one level when I draw the thing. صح? Everything will go up. One level more. One level high. One level high. هنا the load is not uniform. The load is what? The load is linearly increasing. Ladies. The load is linearly increasing. صح? So, since the load is linearly increasing, that means what? PP means what? The load is linearly increasing. So what will happen with the shear force? The relationship will be linear?
No.
It will be what? Quadratic. صح? طيب. So the bending moment will be what? Cubic. صح? Everything is increasing in order. Everything is higher in order than the thing that was before. So the shear force diagram now, I'm expecting a quadratic relationship. شكلها ازاي بقى? We'll talk about it. Okay? طيب. What are the points when we start أصلا? What are the points that I know? In the shear force diagram, هنا I'm at the tip of a cantilever, صح? Is there anything beside me? Is there anything acting there? So actually I'm starting from zero. This. مش كده؟ And we said what about the shear force diagram? We said that we need to always take a section before and after each change in the geometry or in the load. You agree? We said that. فهنا I'll take a section just before my 16K reaction. حلو؟ He gave a name for this point. This is A, B, and this is C. Okay? Right. So, if I take a section here, what do I see? Please. I'll take a section for the ease of the thing. I'll draw the section out. I'll draw this section out. So this section I'll draw it here. So this section is actually this triangle. And this dimension is 6. But what's the height of this triangle, Cam? Rob. Similarity of triangles. So I can get this height using similarity of triangles. So if I call this height W1 مثلا, okay? So W1 over 6 is equal to the 3 over 24. Wow. Therefore, W1 is equal to 3 times 6 over 24, which is 1/4. So this is 3/4, 0.75. Okay? So this W1, I proved that it's equal to 3 to 0.75 kip per feet. So 0.75 kip per feet. What does that mean? That means what's the area of this triangle? But that's the only force I'm having, صح? Going down. So what's the area of this triangle? So I'm having 0.75 times 6 over 2. صح؟ مش كده؟ طيب. This is negative because it's going down. صح؟ This is negative. So this is 3 times 0.75. This will be negative 2.25. Do you agree? Where is it acting here? مش فارقة معانا قوي, but where is it acting? We'll use it later. So it's acting at 1/3 from this distance. So this is 2 feet. Do you agree? So this is the resultant. So this is this negative 2.25. Okay. So هنا, when I'm drawing this value, this will be negative 2.25 here. Then, if I take a section after B, just after B, this negative 2.25 will receive the 16. So what's the ordinate here? The value here will be what? 16 minus 2.25. Do you agree? After B. After B. Do you agree? It received the 16K up. So 16 minus 2.25, so this is 13.75K. Here I'm having a jump. I know the shape here. This is 13.75. اوكي؟ هي كبيرة شوية. اوكي؟ معايا؟ طيب. If I come here and I take a section, who is this? What should be the value? Just
Here?
to see. ايه؟
Just كده
What should be the value?
ولوكال this way ولا
But if I'm looking this way,
دي؟ لا
the active action,
اه
the 20. بس خلي بالك the sign convention will be reversed. But will be negative 20. If you want to do a check of what you are doing, look there. That's a check. Going, look, take a section, look there. You will see what? I hope. But take a section and look there. I'll see the 16 is positive minus what? Ladies, minus what? The whole triangle, the big triangle. 3 times 24 over 2. So 3 times 24 over 2, this is 3 times 12. 3 times 12 is what? Negative 36. And this is 16, so this is exactly negative 12. So this is yes, it is 1. So this is extreme show negative 2.25. This is negative 1. شكل ايه؟ انا بقى ايه؟ ممكن بقى نقعد نتكلم مع بعض كتير. What would be the shape here? We said it's not a straight line, صح? You agree it's not a straight line. We agreed that it's not a straight line. So it is a polynomial. It is a quadratic
ناخد
equation.
point من النص
هو the point here is what? حلو. ناخد point في النص ونشوف الفاليو كام. That's a good idea. Take a point in the middle and look what's the value. If I take a point here at 9 feet. Okay? At point at 9 feet. مثلا 9 feet يبقى هي 9 feet من اليمين و 9 feet من الشمال. صح؟ And I'm looking here at this triangle ده. هنحسب ده. So this triangle اللي هو جاي له ايه؟ جاي له 16 feet هنا. 16 كده انا اسف هنا. So this is 9 feet and this is 6 feet. So this total distance is what? 15 feet, صح? You agree? This total distance is 15 feet. And this is going like this down. Now what's that ordinate? Let's call it W2. W2 دي تطلع كام؟ نجيبها ازاي؟ برضه similarity of triangle. So here W2 over 15 is equal to 3 over 24. نفس الفكرة بالظبط. Okay? So W2 is equal to 15. 3 over 24 is 8 actually. So it's 15 over 8. 15 over 8 ده حد يحسبها. 15 over 8 ده 1.875. حد يتأكد.
15 over 8
15 over 8 طبعا. اللي انا بقوله ده في حاجة غلط. ليديز في حاجة غلط. ولا صح؟ صح. 1.875. صح؟ هتتطلع كده؟ So this 1.875 kib per feet. This is W2. So if I go and calculate the area of this triangle, so here I have برضه negative ما هو نازل لتحت negative 1.875 over 2 times the distance which is 15 minus the 16 بقى أنا آسف plus the 16 16 طبعا فوق. Okay؟ plus 16 فيطلع الرقم كام؟ حد يحسب لنا الرقم ده كام بالظبط؟ That could not be a big number. يعني do you agree that it must be between these two numbers? Somewhere between. صح؟ طلع بقى كام؟ يا بنات
ما هي كانت بتبقى
معقدة أوي كده. أسهل حاجة. 16 minus 7 for that times 1.85 equals of 16 minus 1.875 times 7.5.
$1.9375.
1.9375. لكن رقم صغير it's approaching zero يعني. Okay, so it's somewhere here. Okay. So actually this thing will look like this. This is what this is telling me. Okay, in terms of concave. تمام. And which makes sense in zero shear يبقى أقرب to this side. Why? Because the load is larger than this side. فهنا you're expecting the maximum bending moment to be nearer here. تمام. And this thing is expected برضه ان هي to be having a similar behavior. Let's say to be concave. By the way, حتى concave up or down does make a big difference for us. يعني ايه؟ يعني you do not have to know it by heart whether it's concave up or down. يعني خلينا انا لسه ما كملتش. But يعني you're expecting the same shape more or less to have something like this. Similar equation. Okay? But what makes a real difference for me in the shear force diagram is two things. The values, the maximum values, because in terms of design, when you go and design, you will be designing based on the maximum values. You should not get it wrong. Anybody? All these jumps, the maximum value, then different values. Then this is 10, yeah. This makes it 20, مهمة. This 13.75 is very important. Okay? This 2.25, these values, they are important. Okay? Yes.
يعني ما خدناش section بعد فيه.
وزير نرجع بس ما هو احنا وقفك فعلا لما ناخد section بعد C it will receive the 20 and it will close. وده فعلا اللي حصل على فكرة. We already did that. Okay? بس يعني I didn't spell it out. But we already did it. Okay? طيب. Let's talk about the bending moment. The second important thing about the shear force diagram is the location of the zero shear. Because this will tell me where is the maximum bending. Okay? So يعني the location of zero shear هنا يعني تقريبا because at the line it was here positive, so maybe the zero shear here will be at about 8 feet. More or less. Approximately. Okay? وصعب جدا ان احنا نجيبها بالظبط because this is not linear interpolation, this is not a straight line. تمام؟ This is something that you can get by trial and error. Okay? طيب. So I know بقى هنا ايه؟ What do I know in terms of bending moment? First thing to start with the bending moment, first thing to do is to get the points at which you have a zero moment. أصلا. Zero. Where do I have zeros here?
عند الماكسيمم.
Zero moment. Bending moment diagram اهو.
أنا افتكرت
لا bending moment diagram. لا bending moment diagram. Where is my zero?
عند الماكسيمم.
At point A, the edges.
اللي هو ال A وال C.
See, my edges. ما انا جنبي هوا خلاص يعني. There is nothing beside me. So at the edge there will be يعني there's no bending. مفيش حاجة. There is nothing to bend me here. Okay? خلاص؟ طيب. So this point and that point. أكيد دول zeros. But what else do I have? So I need what?
maximum عند الزيرو.
I need to get which points else? I need to get a moment at B. And look at the zero shear نشوف هنجيبها ازاي. Okay? تمام؟ طيب. So this point B. Point B. I look here. خلي بالك we already did the calculation here to get the shear force for this thing or the load acting here. And you know this distance. يبقى what's the moment at B? خليني اعملها بلون تاني عشان تبان. What's the moment at B? The moment at B is simply what? This load, the negative 2.25 times the distance, صح? Which is 2. So this will be negative 4.5. Okay? Feet. Now. Okay? أولا يا جماعة ما تنسوش تكتبوا اليونتس دايما. You must always write the units. This is kips, kips, kips. This would be good. How does the shape look? It will look like this. Does it have a maximum? How do I know that it doesn't have a maximum? How do I know that it didn't go like this? Because the shear force diagram didn't cross the zero. Now this shape does not exist here. فاهمين الفكرة؟ So you ladies, you need to understand this. You're not integrating or differentiating anything here, but you need to understand the relationship. You need to understand that there's the relationship between the bending moment and the shear force, this integration relationship between them, in order to understand whether you are doing something right or wrong here. Okay? تمام؟ طيب. What about what's happening here? I know that this is the maximum. The maximum is somewhere here. Yeah, this is a 0. This is so 3 points. I need 3 points out of this, and that one. But what's that one? This is actually a section. بصوا بقى. I'll take a section. At a distance of 8 feet from this side, which means it's 10 feet from that side. Okay? Okay? So in this section, what will I see? If I take a section and look there, I'll see what? Triangle and a 16, and that distance is 10 feet, that distance is 6 feet. Do you agree? Ladies, hello, beep beep. You know what's the thing that's worrying me most? إن حاسس إن البنت دي وقعت مني دلوقتي. What will happen with the rest يعني؟ إن شاء الله. Hi. You get what I'm doing now? I'm getting the maximum moment. I knew the location of the maximum moment. I knew that this is the zero crossing of the shear force diagram due to this relationship. Fine. So because this location, I know the location here, I'm taking a section at this location and looking at that side. The other option would be to look there. مش فارقة. By the way, doesn't make any difference. Even this one is easier because I'll deal with one triangle. هنا I deal with a trapezium, which is the triangle and a rectangle I need to divide. ايه؟ That's another section. Okay? So that's the third section. I'll call this W3. Okay? So this again برضه similarity of triangles. W3 over 16 is equal to 3 over 24. As simple as that. So this is actually 2/3 of the 3. W3 equal 2. That's the رقم في الليلة دي كلها. صح؟ So W3 is equal to 2 kept everything. So if I want to calculate the values بقى, what I'll have here as positive moment will be what? The 16 times the 10. There be it's minus. 16 times 10 is minus. So here's 16 times 10. This is positive. Minus this big distance, which is by coincidence 16. أو خلينا نبتدي باللود. The load times the distance 16 over 2 times the centroid of the load, which is what? The distance 16 over 3. صح؟ اديني كام؟ اديني كام؟ So 160 دي هتروح مع دي. So 16 squared. 16 squared is كام؟ 256. 256 over 3. So هنحسبها 160 minus 256 over 3. This would be maybe 70 something.
74.6.
74.67. Okay. اهو. This is 74.67 kg. Okay, this is my bending moment diagram. Okay, right. Clear? Crystal clear? ربنا يستر. Okay, let's move on. So let's compare our numbers to his numbers. سبحانك يا رب. سبحان الله. Okay, فيكم شيء لله والله. Exactly same numbers. Exactly. Okay, طيب. I'll go to, because there is a specific idea I want to discuss today, other than these ones. This thing. What's that thing doing here? يعني لو مش عارف ده هيبان على الشاشة ولا مش هيبان ده. What will that thing cause? Having these brackets كده. ايه المنظر ده؟ What will that cause? فاكرين when we replaced forces with force and moment والحاجات دي, when we changed the location of forces in the previous part of this course? Remember that? لا؟ لا. فكر.
مش فاهمة
حاضر. So let me keep this for a while. Let me erase the symbols. Okay, so هو الاسود اللي كان بيعمل مشكلة في الدول. ماشي. So what's happening here is what? Also, ladies, what I'm having is I'm having this thing and this thing like that. He's having a force here and a force here. Force here. This is 5K. This is 15K. This is 30K. This is a roller. It's calling it C. And this is a hinge. It's calling it A. والمرة دي تحديدا هو ما ادانيش الرياكشنز ولا حاجة. Okay. We replace this. خلي بالك هو this height of this thing is 4 feet. The height of this thing is 6 feet. This distance is 12 feet. And this distance is 8 feet. يعني I'm not drawing it to scale أوي الحقيقة يعني. نقرب ده كده شوية وكده كده بقت 8 feet. Okay. خلاص. This is point A. طيب. We are replacing this, ladies. Look at me. I'll draw it in a different color. I replace this with another easier system because خلي بالكم هنا. I'm not interested in the vertical members for the time being. I'm not interested in the vertical members. So, when we talk about frames, we will do these vertical members. Okay? But we're not interested in them now. We are looking for the bending moment diagram here. حتى هو بيقول لي for ABC. The shear force and bending moment for ABC. Okay? This is A, B, C. Okay? This is B. تمام؟ فهنا I will replace these forces, the locations of the forces are changing. So each force will be actually a force and a moment instead of a force. صح؟ We said that. So let's start with this one. 30K at a distance of 6. So that means in terms of moment, it's what? What's the moment? Okay, yes, bravo, صح, 180, which is 30 times 6. So this moment, I'll have a moment like this, depending on the arrow, the arrow is this way. It wants to rotate like that. I'll have a concentrated moment here of 30 times 6, which is 180 kb feet. Bravo. تمام؟ طيب هنا او خلينا اقول برضو in addition to a 30 kip force الفورس اتحركت نزلت معايا تحت اوكي بس this force is axial to my memory انا it will not affect خالص وده demand moment تشيل فورس يعني مش هيفرق معايا اوكي طيب هنا ده 15 is the 15 ده 5 انا اسف ده 5 كي هي نازله لتحت كده 5 كي مش فارقه the 5 كي is going down بس what will this force cause at B
15 times 4.
برافو so هنا I'll have another moment like this اوكي خلينا نقسمه كده عشان يبان احسن 15 times 4 خليني حتى معلش انا هقسمه فوق ال 5 او كده هنا 15 times 4 okay so this is actually what's happening there 15 times 4 which is 60 kPa and this is point E خلاص تمام so in terms of shear force diagram هي مش هتفرق على فكره يعني the concentrated moments مش هيفرقوا قوي they will not directly affect the shear force diagram but they will affect the values of my reactions do you agree and if I take a moment my reactions if I take sigma moment about A equals 0 I'm getting the reactions all over to get YC I'll have 20 times 1 C يعني this is my خلينا نقول this is the positive sign so this is the positive sign convention the 180 cap fit will be what positive or negative positive minus the 60 you agree and the 5 will have an effect it's A positive or negative positive here كمان and this distance is what it's 8 feet on so minus and that's plus 5 times 8 minus what YC times 20 20 is the whole distance تمام therefore YC تطلع كام oh this is 180 minus 60 this is 120 plus 40 this is كام 160 over 2 يبقى over 20 يبقى 8 kips okay up طلع فوق okay mainly because of this thing by the way دي اكتر واحده ضغطت عليها خلاص sigma Fy equals 0 equals I'll have what the 20 sorry the 8 that I just calculated plus YA minus 5 خلي بالكم the moments will not affect the sigma Fy خالص okay minus the 5 therefore YA is equal to what negative 3 okay ده معناه ان هي this thing wants to go down كده نازله لتحت kips and this is going up 20 kips which makes sense because this thing wants to flip over يعني عايز تقلب wants to flip over due to this big moment okay عايز يقلبها طيب يبقى when I draw my shear force diagram I draw it in that شكل مختلف again you will not see the moments there these concentrated moments they will not translate in the shear force diagram خالص two you only see the force okay however they will have an effect and remember when I told you before that there is one exception in the case of where do you take the moment I told you it will not make a difference you take a moment just before the point or just after the point so you take a moment at the point this is the exception case if you take a moment just before B it will be totally different than just after B just before B حاجة or just after B حاجة تانية خالص okay so you need to take both points because there will be a jump in this بس خلينا نتكلم عن shear force first shear force diagram I have the 3 going down like this is there anything until receiving the 5 no so this is negative 3 constant then a 5 going down this will be negative 8 now then ايه اللي انا بعمله ده 20 ايه بس ايه اللي انا بعمله 20 ايه ده انا اسف this is an 8 That's an 8. Negative 8. Then negative 8. Here it goes to the support. It receives the 8. It closes to 0. أهو قفل أهو. Okay? خلاص؟ Okay. طيب. Let's talk about the bending moment diagram. Bending moment diagram. بصوا بقى معايا. Again, at this point, I know that this point is 0 أكيد. For sure. There is, خلي بالك, at the edge, there is nothing beside me, and there is no concentrated point. So this point is 0, ده أكيد. However, what's happening here, لا, I'm having a concentrated moment. It's another story. Okay? طيب. هنا بقى we said this is the exceptional case. You need to take a section before B and after B. Okay? And before C and after C. So before B, يطلع كام? What? Just before B, it will be 8 times the 3. Is it positive or negative? Negative, it's sad. Okay? This is negative 24. Okay? So here it's negative 24. What's the relationship here? Straight or curved or what? Straight line. That's a negative 24. 50. But if I take a section just after B, what I'll have is the same negative 24, so negative 8 times 3, and something else which is more negative or positive. Let me show you the sign convention again. This 60 kip feet, is it negative or positive? Is it sad or happy? Negative. Okay? So, this is negative 60. So this is negative 84. حتى خليني يعني التسكيل بتاعها مش حلو قوي يعني. Negative 24 will be something small like that. And it's receiving this negative 60. I'll have a jump here. I'll reach negative 84 kip feet. So, what will happen here? Let's take a section just before C. Let's take a section here. Look there. Okay? What will we see? We'll see the negative. The 3 will be multiplied by what? 20. Right here. From here. So this is negative 3 times 20. يا جماعة negative 3 times 20. And what else? The negative 60. ثابتة معايا. Is there anything else? Is there anything else? No. So this is negative 120. في حاجة تانية؟ في the 5. So here هيبقى معايا كام؟ Is the 5 positive or negative? لا negative 1. So minus 5 times 12 يبقى عندي هنا negative 1e. بصوا بقى. This is exactly equal to 1. فهنا على receive a negative 1e هيبقى عندي البتاعة دي هنا راسمها بايظة خالص. أنا هيبقى هنا معلش بقى السكيل ضايع. عشان نعرف نعملها عادي. So this was negative 24. Then it's negative 84. Then I'll have a negative 1 equal. And you notice something very interesting. If I take a section after C is 0, خلاص هنزل to 0. You notice something very interesting, that the slope of this line is different than that line, because there are different shear forces. And we said that the shear force is the derivative of the bending moment diagonal. Okay?
هو في بي لما خدنا بعد بي ليه ما حطيناش الفايف فيها؟ لما خدنا
The distance is negligible. The perpendicular distance between, you're just after the beam, maybe see 1 millimeter. So 5 times 0.001, بلاش 1 micrometer. 5 times 1 over 1 million. فاهم قصدي؟ يعني is nothing, instantaneous. Okay? But that's a good point. تمام؟ So let's compare our numbers to his numbers. ما شاء الله ما شاء الله احنا ماشيين حلو اهو. حتى he's doing a check, a very nice check here, which is the area. And he's calculating the area of this rectangle. It's equal to negative 24. The area of this rectangle is negative 96. So together they are the negative 180. Okay? So it's exactly the thing. And if you go and check the deflected shape, this is the deflected shape of something, and this thing wants to go bumps up like that. And this is how it wants to deflect, wants to go bumps up. And by the way, one of the interesting things برضه will go into this course بس مستني عليها بس شوية ما كنتش عايز ابتدي فيها على طول is how this deflected shape you can sketch it. Because this is something very important when understanding the issue with the bending moment and this. تمام؟ Any questions?
هو يفرق لو رسمنا النيجاتيف فوق تحت في المومنت؟
For our exercise here in Egypt, it's very important to draw the negative up and the positive down. Why is that? برضو again, because our scope here in Egypt, we are mainly talking about reinforced concrete design. But how would that make a difference? If this is a reinforced concrete element, this is a reinforced concrete beam, you want to place, in such a case, it's only carrying negative moment, but you want the reinforcement to be always an upper reinforcement. Your main reinforcement will be the upper reinforcement, forward. So, if I draw a cross section of the beam, the steel bars will be up, they're not down. Okay? That. However, for a simply supported beam, like this one, هنا مثلا, here, you will have the main reinforcement in the mid span down. At the supports, there will be negative moments here to be up. So it helps you to understand at the design stage where will you place this. But this is why in Egypt we focus a lot on this issue. However, in North America, they are using the convention that the negative is down and the positive is up, because simply speaking, they are designing steel members in most of the cases. But designing a steel beam, it doesn't make a big difference whether the moment is positive or negative, because you are designing it as a member, as a whole, and you will be placing the I-beam. You are not reversing the I-beam or the hack. You are just placing the I-beam as is. Okay? If you are talking about a standard section. تمام؟ خلاص؟ But that's a good point. فلا, please don't do that يعني. Okay? Any questions? Okay.